So with that said, let me introduce Kumar Sarab, who is one of our co-founders and also our VP of Engineering. And Kumar started Sumo Logic along with Christian Biedgen in 2010. And in addition to obviously running the engineering organization, one of Kumar's central roles has been instituting, building Sumo on Sumo. So we use Sumo Logic to instrument and monitor and troubleshoot our production systems and a variety of other systems as well. And the point of today's conversation is to help you understand the different ways that log management and analytics can be used for everything from DevOps groups to IT organizations to even support and sales and marketing for that matter. So with that said, let me turn the floor over to Kumar and let him go ahead.
Perfect. Thanks, Sanjay. So first of all, hello everyone, and thank you for taking the time to join me on this webinar. As you're all aware, we are a cloud-based log management company. We started at this point almost 2.5 years ago, but the first time when we brought up the service online, we realized that we ourselves need a log management and analytics solution. We are a software as a services company. That means the responsibility to run the system, to make sure it's available, make sure it's performing, relies on us. And so in engineering and operations, it has become a really critical tool. But over the last couple of years, especially in the last 15 months or so, what was a pleasant surprise is that other departments within Sumo Logic are also very heavily using the Sumo Logic product, all the way from sales teams to product teams, and even in marketing, we use Sumo Logic to get answers from the log data that we generate. So before I dive into and talk about some of the use cases, I wanted to just kind of take a moment to talk about the setup that we have got here inside the development organization. We fully adopt the DevOps model. So, the development team, we have dedicated folks who do operations, but primarily the entire development team, especially the backend teams, are carrying a large portion of the burden of operating the system. People carry pagers, get woken up at night if there is a hiccup in the service. We use cloud services quite a lot and push code to production every week, at least once every week. And some of you might be aware that we run in the public cloud. We are 100% based on AWS and EC2. And there are a couple of tools that will look familiar to you, like Ganglia and PagerDuty, that we also use quite heavily over here. And for logging, of course, we use Sumo Logic pretty much. And that's how our development, how our engineering and operations organization is set up. But in order to analyze, in order to ask questions of the log data, have visibility into how the system is operating, we need to collect all that log data. And since we are ourselves a log management company, we started another instance that we are calling here the shadow instance. So we have the production service where all our customers have accounts, and Sumo Logic also has an account on that system just like other customers. And these customers are coming to us, many of the people are already running, either 100% in the cloud or are running a significant portion of their deployment in the cloud. But there are a lot of customers who are actually collecting data primarily from their on-premise environment or data centers and so on. And what we are doing is we are collecting log data from various departments. Like in QA, we do run a lot of performance tests, and we take all the logs and feed it into Sumo Logic. But the one thing that is most important of all is the log that our service ourselves generates, because that's the log data that we need to look at if we are troubleshooting an issue that's reported by either a customer or our support staff or an SC in the field. And so we generate about 200 gigabytes of log data a day. Our production instance is running over 100+ nodes in the cloud, and on a daily basis we generate that much data that we collect and feed into the shadow instance. And the shadow instance itself generates a much smaller amount, more like 20-25 gigs of data, and we take that and feed that back into our production instance. That way, when we need to troubleshoot an issue in the production instance, we can log into shadow instance and do that analysis, or if there is a problem that we need to troubleshoot on the shadow instance, we can log into the production instance and do a very similar troubleshooting. So that's how our log infrastructure, our log collection infrastructure is set up. So what I have seen in my own daily life, if not on a daily basis, at least several times a week, I end up following a workflow where someone comes in with a question or an issue that I need to provide them answers for. And the first phase of my analysis will be traditionally what we would call forensics or troubleshooting. And then once I figure out, what was the nugget of insight in course of that investigation, then once in a while I want to visualize that data. I want to put that on dashboards so that it's always available for me to take a look at quickly. Or sometimes I want to set an alert based on that and get alerted when something like that happens again in the future. So what I'm going to do is I'm going to walk you through, what is a typical workflow for me? How do I typically use the product? And walk you guys through a scenario, and I'm hoping to expose, different areas of the product to you in that process. So let's start with a troubleshooting use case. So every once in a while, I'll get a question from one of our support staff. In this case, yesterday, one of our sales engineers, whose name is Damon, asked me, "Hey Kumar, I have a scheduled searches running, and can you log in and tell me how much time it takes to run those queries?" And so I knew we had the data in our production. We know we generate that kind of log data. So I will walk you through how I can search through that, find those search sessions, and answer Damon's question. So let me actually switch to our product for a quick second. So what you're looking at here is our production instance, and we all use one password because we insist on having a strong passwords. It's very hard to remember random passwords. So this is our product, and it is the production incident. So production instance. So the logs that we are seeing here are the logs that are generated by our shadow instance. So the first thing I do is I know that Damon was running those searches. The question was about the searches that he was running yesterday between 9 a.m. and 10 a.m. So I'll change the time limit to say, hey, I want to ask those questions between 9 and 10 yesterday, and I know Damon was the one who was running queries, and in the log lines, and in the logs, I know that I have, whenever someone runs a search, we generate a log line saying we are starting a stream query. A stream is our internal name for the cluster, for the query engine that we have. So when I start running this query, what I'm expecting to see here is all the searches that are coming in, but we might get searches that are both scheduled and unscheduled searches coming from this particular query. So we can start seeing that there are a couple of log lines showing up here. 2 more log lines showed up. I'll give it a few seconds to kind of span the entire 1 hour. But I'm starting to see that it is showing me some log lines where the entire phrase is not there. So the log line number 4 is what I really wanted, where it says starting a stream query in one phrase, but I didn't want to see the query, the log line right before it. So I can get to that by simply putting quotes around that, so it's going to look for one. So it brings back only the most relevant, the most relevant set of log lines from that time period. Okay, so I start getting these logs, and in each of these log lines, what I'm looking for is when did these sessions start, and what I'm noticing here is that all the sessions are starting every 15 minutes. So that's a clear sign of, scheduled queries. So these queries are running every 15 minutes, and I can see the start messages. But in order to answer, how long did the query take, I need to find out when did this query end. And I'm only interested in finding out, the end log lines for these 4 sessions. So what you notice here is that whenever we start every query, we spit out a random session ID. So I'm going to take one of the session IDs from here, the first query that shows up, or let me pick the last one. And I'm going to say, let's look for that session, and I'm interested in looking for starting a stream query, or give me log lines that have the word finished in it. So what I'm hoping to do is get the start log lines and the finished log lines for this particular session. Okay, great. And so now I'm going to look for one log line here that says query session finished, and it has the same session ID. Now, we have an operator that we call SessionEyes, and what the SessionEyes operator does, it can take 2 log lines and turn them into a session. It threads the 2 log lines by using a session ID. So I can use the SessionEyes operator to piece together these 2 different kind of events, one that marks the start of a query and another one that marks the end of the query. So what I'm going to do is I'm going to take the same session ID, put it in here, and look for this, let's look for one of the, when the query starts. So there is one piece of log line in here that I go and say, okay, SessionEyes. And SessionEyes basically takes, a part of the log line, and by putting a star in there, what I can do is I can extract that particular value as a session ID. And this is what we call an anchor expression. So it is able to extract that because it has some string in front of it, session ID equal to, and it has a comma afterwards. So it knows how to match that, extract that value, and that will be the session ID. In order to tie it to the query, to the ending query for the same session, I will have to find out the end log line with the same session ID. So here I go, copy this over. And the crucial part in here is to use the session ID that we extracted from the first one in the second log line. So I'm going to say, I put this thing in here, and now what I have done, I've defined a session that has 2 stages in it, the start and the end. But you can do the same trick with as many stages as you want to add. So I want to make sure I'm searching in the same time range. So let me just copy over the time range here. And so it will go through the same set of events, look for the first log line, extract the session ID from that, and then it knows what the second log line should look like, and it will try to match the incoming stream for the query session finished event. And so what you're seeing here is I get the first log line and the second log line, and it assigns a new field in there. That's the session attribute. That's the session ID. Is the same session ID. I can see that the query started at 5102 and finished at 5106. So it took about 4 seconds. So the next follow-up question would be, okay, for this particular session, it took about 4 seconds. How much time there are probably many other queries running in the system in that hour. How much time did all of those take, and how can I characterize, how can I find, let's say, 75 percentile number, or how can I find the slowest query that is running in that time window? In order to do that, all I have to do is now let go of this and run this against all the sessions. And so now I'll start seeing for every session the start log line and the end log line, and I can take a difference between the times when they happened, and that would be the time that the query took to finish. By the way, you can do exactly the same thing using a parse operator. So parse operator is very similar, but parse operator only works at one log line at a time. So let me tweak the query a little bit to show you how you can do this using the parse operator. So in order to do parse operator, I just replace the word SessionEyes and I extract the session ID from the first one, and then I can also put a parse operator and extract the session ID from the ending log line, and this shows up as session ID. And so I run the query, so one thing that is happening here, it's not finding many of the hits because every log line either match one or the other, but not both. So one of these parses will actually drop either of those sessions. So one thing that I need to do is add a no drop option in there. And what that basically says, for the finishing log line that would not match the first one, let it pass through so that it can match the second one. And when I run this query again, I should now start seeing a whole lot more hits. Okay, so now it looks like it's finding all of these different sessions in here. As I said, what I want to do is group them by sessions and calculate the minimum and the maximum time. The minimum time will actually give me the start time, and the maximum time will give me the end time. So every log line has this field called message time, and it's a field that's available on all of them. It ships by default. It's always there, so it has an underscore in front of it. And that's my start time. And the last log line will be the end query. So I take the message time from that and call that the end time. And I do that for every session. So now you'll notice that a new tab shows up that will show me the aggregate data for various sessions. Okay, so I can see the start time and the end time, and if I subtract the two, it will give me the time taken. But again, these are raw time fields, so that will be in milliseconds. So let me actually divide it by 1,000 to see time taken in seconds. And notice in the last statement, what I'm doing here is replacing time taken by 1,000 to time taken. So you can keep overwriting that field as many times as you need to in that query pipeline till you get it to the point where it looks how you want it to look like. So I can see all of these sessions showing up here. Some of them are taking, close to 1 second. There is one in there that takes about 15 seconds. There is another one that takes a minute and a half. So there is a lot of variance in this data. And so what I really want to find out is how does the query time, query time is a factor, first and foremost, based on, what's the time duration of the query. For example, let me just sort by time taken, and I'll look at one of the queries that will take the longest and try to figure out, why is that query in particular taking that long. Let me actually get same time range here, and want to okay, so let's take the session ID in here, and I want to put that session ID, and I'm going to look at the first message. So now I have the question in my mind is, okay, that query took the longest, and what is about that query let me just start here. What is about that query that's taking, I think it took more than a minute and a half. It used to be one of these queries, 100 seconds or so. So what I can see here is the query. I can see the query ID. I can see the timestamp in here. And the timestamp is actually written as a long value, so I'll have to calculate the difference between those. But let me actually just look for all log lines and look at one of the earlier logs in there. Okay. So I'm starting to look for one of the early log lines, because some of the earlier log lines will actually give me the start time and the end time in a much more readable format. Human readable. Okay, this seems like it, and it says from 9:51 March 25, 9:52. It's probably it's Kevin who was running the query, and he was running a summarize operator. So summarize operators look at all the data, and it's one of the heavier operators because it does this log reduce thing under the hood where it tries to infer signatures automatically. So now I know why one of the queries took, where most of the queries were taking 4 or 5 seconds, why was this query taking 100 seconds? So this is the kind of troubleshooting I do all the time. And another thing that, so I do these queries, I know there is a lot of variance in the query data, so I define a performance metrics, and the way we define that is what is the 75 percentile time that it takes for queries to run to kind of see a number in aggregate. And so in order to do that, I would have to first, I want to see that statistic by every 5 minutes, and for that we have an operator called time slice. And so I'm going to take all of these sessions and I'm going to attach a time slice to that. Time slice is nothing but a time bucket. So it takes all the different queries, puts them into 5-minute buckets. So let me call that time slice field as time bucket. And now when I'm getting these, once I take all the queries, put them into time buckets, I want to calculate the 75 percentile number within those buckets. Okay. Now it's it is not very happy because it cannot find the message time. That's right, because this time slice operator needs to work before the first aggregation that I do, because by the time I have done the aggregation, I have already lost the message time. So I move that up there and run the query again. And now it is complaining to me that it cannot find the time bucket, because when I did the group by, I only grouped by the session ID and not by the time bucket. So what I will do, the time buckets more often than not are going to be the same. So I am going to put minimum of the 2 time buckets is time bucket. And so on the aggregate tab, I should now start getting for every time bucket the queries that ran and the time that it took, and among all of those various times, the percentile operator basically sorts them and will figure out, what is the 75th percentile number for that hour. And again, the time bucket that is printing out, it's printing that out as a long number, which is not very readable. So I want to, translate that into a readable number. For that, I can use a format data operator and say, the number that I have is in millis, and I basically can do this, and let's call this time bucket. And before I do that, I also want to sort by time bucket. That it shows up in a nice way. Okay. So I'm missing the time format in here. So let's do that. Run this again. So now when the results are coming back, I should have all of these time buckets in a very human readable format. Every bucket should be 5 minutes, and it should be sorted by that time bucket value. I can actually take the result set that I'm getting here in a tabular format and turn that into a bar graph. And now I have this interesting statistic that I can visually see. I would like to add that to a dashboard. And in order to add to a dashboard, the dashboard is evaluating these queries as more and more data is coming in. So it needs to be able to, it needs a relative time, because it will look at 3 hours, last 3 hours say, and the last 3 hours keeps moving. So what we have to do is change that fixed timestamp into something that is a relative timestamp, like -3 hours or -1 hour, and then using the Add to Dashboard button, we can now add it to a particular dashboard. Luckily, I have this dashboard already, and what I'll do is I'll launch it up, and I can show you how that exact chart looks like over last 3 hours. So one of the charts that you're seeing at the bottom on the left-hand side is exactly that same query that takes by 5-minute bucket added to this dashboard. So I can bring this dashboard anytime, and I can look at what was my 75 percentile response time over last 3 hours. And you can see a spinner here, and that's because the results are getting refreshed every few seconds, and whenever new data is available, as more data comes in, the results get updated in real time. So that's the functionality of taking a query, figuring out some insight, visualizing it, but we can also very quickly turn that into an alert. For example, in here, I would want to say, if the time taken is ever longer than 2 minutes, then I would want an email to be sent out. So all I have to do is I say time taken is greater than 120 seconds. Let me save that as a query. So I give this a name. And I basically say run this every hour, run it over last hour worth of data, and notify me only if there are at least some results in there. That means there is at least one query that took longer than 2 minutes, and I need to put my email address so that it knows where to send that email to, and save it. This way, that query is going to run every hour, and whenever it finds a query with a slower response time, it will send me an email. And that is how I can quickly get alerted based on conditions that are interesting to me. So I have, let me quickly switch to the presentation here. So what I have shown you is not only to do troubleshooting, but how to take some of the key insights and turn that into performance metrics, how we can use dashboards to visualize that, convert some of that, and maybe get alerts based on when the numbers that you observe are slower or faster than what I'm expecting, and get an email on that. And the dashboards are a great tool for actually visualizing a bunch of monitors in the same place. We have a couple of TVs in the office in the development area where we have dashboards rotating through, so we can see those key metrics update in real time. Another interesting thing that we also do, and going back to that dashboard that I was showing you earlier, what I'm showing here is the number of queries that people have run on the shadow instance to troubleshoot something on the performance incidents, and I did not cook it up. In the last 7 days, I actually have run 1,600 or so queries on our own system. And there are a lot of people use, even Vance is showing up in terms of his scheduled queries that he's running, and they're obviously all across the company development. I see one of our product managers, one of our QA folks in here, running searches, getting reports, sometimes doing troubleshooting, and so on. So, this is what we have got in our logs, and there is tremendous amount of insight, tremendous amount of clues buried in all of those logs, and there are a lot of people who are looking at logs to ask questions and get answers that make sense in their own business context. I would be very curious to hear, what kind of data you have in your logs, and what questions do you want to ask of those logs, because I'm pretty sure that a platform like ours, a solution like ours, can actually fish those answers out and present to you in a very visual way. And now I'll open the floor for any questions that we might have got.
Thank you, Kumar. Once again, just as a reminder, you can ask your questions in the Q&A panel that's in the WebEx window in front of you. And just as we're waiting for people to ask questions, a couple of upcoming events. We have actually with Bruno Kurtik, our Vice President of Product Management and Strategy, is going to do a deep dive on actually the whole search functionality within Sumo Logic. So this is relevant for people who are either on Sumo Logic Free or existing clients of ours. You can always ask questions. We've got a number of other webinars that are designed for both deep dives as well as broader overviews of topics. But if you have questions about our webinars, you can ask us then. And obviously, for those of you who aren't already on Sumo Logic Free, if you want to check us out, you can do so as well. So one question, Kumar, that's come in has to do with sort of benchmarking, and you talked a little bit about, for example, 75 percentile benchmarks, but does Sumo Logic use metrics from logs to benchmark specific engineering or operations activity?
Yeah, we do that quite a lot. What we end up doing is we look at we draw up the system architecture and say, along every blocks and edges that we draw on that architecture diagram, we say what are the key performance indicators that we need to know about. And the demo that I showed was basically along the search path, but we have a very similar kind of a statistics around how is the performance on the ingestion path, how is the performance looking in terms of our continuous query engine that drives the dashboards that I showed, and how is the performance looking across other subcomponents that are under those layers. And we have all of those. I mean, the logs look very similar, so you'll see typically log lines that say, time taken to do this is XYZ. Sometimes it's very nicely calculated. Sometimes we have to actually piece together different log lines in the flow of an event and correlate that, and then calculate the differences like I showed with the SessionEyes operator. But we do have a whole lot of performance metrics that we extract from our log data, and more often than not, those actually end up on one or couple of dashboards that we look at on a daily basis.
Great. Another question that just came in, do we support alerting via SMS? You showed alerting via email, but do we support it via SMS?
So one of the things, the short answer is no, the long answer is yes. The short answer is, we support email, but what we have done is people have asked us to integrate with SNMP systems, other systems that they have got, and so a month or two ago, we released this ability that we called, scripted actions that you can take. So the way it works is if you deploy a collector, the collector not only collects the data, encrypts, and sends it to us, it also becomes a conduit to take actions. So for example, the example that I showed earlier where on that particular threshold, I had an email sent to me, but at the same time, I can take that result and pipe it to the collector, and the collector can run any script based on what goes out in that. And one of the things that the script can do is send an SMS alert, or it can turn the search result into an SNMP alert and send it on. Or if you have another kind of, a help desk system that you want to build integrations into, that collector script action can actually be used to create those kind of integration points.
Great, thanks, Kumar. Another quick question, do you use logs or the logs from either your shadow or production system as part of your test harness? We
actually do. We use it, one, to run load tests, and load tests in production. We load tests on shadow systems. We also run what we call, sanity and integration tests. So, hey, we have internal tests that, sometimes fail because, the search load is high and some of the searches take longer than an expected time that we have in the test to finish. So we have a whole suite of test cases running that goes against the production instance, against the shadow instance, and we get alerts based on that. So internally we use Hudson. We haven't yet upgraded to Jenkins, but those tests are running every 5 minutes. Some of the tests are very lightweight, and then there are some more heavier tests that run once an hour, and we get alerts based on what those tests produce and what those tests see. And another usage that we have is even before we release software, to production, we have a couple of internal deployments that we primarily use for QA and performance testing, and we pipe those log data also to our Sumo Logic account on the production system. And some of the reports that we need, how is the performance looking for this build versus the build last week, is actually produced as a scheduled report from our production system.
Another question, Kumar, for you that just came in. Can we manually load log files for ad hoc analysis, so log data off a system that does not currently have a Sumo Logic collector that's running on it?
Yes, it is currently becoming possible. This is something that that we are just coming out the door with. So we have the ability to run, from a command line curl style. You can post those messages, and you can turn them, and you can send it to the service. And that, for one of the customers that we have, this was a use case with their support team. This is a customer that ships, 20, 30 machine cluster to their end users, and typically their customers don't want to have these systems talking to the service all the time. But when the support person has to troubleshoot an issue, the first thing that they start, hey, can you send me the logs? And so what they have been working with us to build out is a script that they can run, which goes against the HTTP APIs that we have, the REST APIs that we have, and it looks at a particular directory, takes all the files, and actually uploads it to the service. Again, this is very, very new, and so we'll be coming out with more information, more documentation, more articles, maybe a webinar or two on this particular topic in a few weeks.
Great, thank you, Kumar. If anybody has more questions, feel free to ask them now. And obviously, if you have questions after the webinar is over, feel free to use the URL in the screen in front of you, or the email address, and ask us questions that way as well. But I want to thank you, Kumar, and thank obviously all the attendees for being part of today's webinar. As I mentioned, we have recorded it, and we will make it available to everyone shortly. Thank you, everybody.
Thank you, everyone.